In this section, we're going to introduce the topic called compositions. Now, compositions are rarely touched on in algebra and sometimes might be omitted altogether. That's because compositions, you'll actually see them quite extensively in calculus, so I just want to get you a little bit familiar with the topic of compositions and what they're used for and how you manipulate them. So when you get up into calculus, for those of you that are going to be pursuing higher mathematics, so you won't be freaked out when you see them. So let's go ahead and take a look at a few examples. Let's say we're given the following two functions. We're given f of x, we're told it equals 3 plus 2x minus x squared. And we're also given the function g of x equals x minus 2. Okay, so we're given this information and we want to determine the following. Let's find f of 5 plus g of 5. And this is something that we actually haven't added functions before, but we know how to evaluate individual functions at a given value. All we simply do is plug in 5 for x everywhere we see in our f of x function, and 5 for x everywhere we see that in our g of x function. All we're simply going to do is combine those two evaluations. So let's go ahead and do that. So f of 5 gives us 3 plus 2 times x, which is 5, minus x squared, which is minus 5 squared, plus g of 5, which is x is just 5 minus 2. All right, and all we have to do is just evaluate this all together. So we have 3 plus 2 times 5 is 10, minus 5 squared is 25, plus 5 minus 2. And all we do is just simply combine like terms. So we have 3 plus 10 is 13, minus 25, and plus 5 is minus 20. And we have a minus 2 on the end. 13 minus 20 is minus 7. Minus 7 and minus 2 is minus 9. So we can say that the composition f of 5 plus g of 5 equals minus 9. All right, given these two functions. All right, so far so good. Let's take a look at another one. Let's say we want to find f plus g of 5. Now this is something we haven't seen before called a composition. This is where we have two functions here that we're adding and we want to evaluate it at a given value. Well, all we simply do is we can split these up into the sum of both functions evaluated at 5. So we would have f of 5 plus g of 5. All right, we have a sum of both functions evaluated at the same value. And that's actually what we have up here. So we have this written just in a different form called a composition, and we'll actually get the same thing, which is what we found. This is equal to minus 9. So this is just a different notation called a composition. So I just want to show you that we do know how to do this. This is just looks different. So let's take a look at a few more. Let's find, using these two functions, f minus g. All right, so by evaluating, we mean one of two things depending on what is in the parentheses. If there's a number in the parentheses like this, we want to get a number as our answer. If there's an x in parentheses or no parentheses at all, which means that implies an x, then we'll perform the operation and simplify. We'll just get an expression at the end. And this is actually what we're going to do here. We don't have a number, we don't have an x, but we're going to treat it as the same as if we had an x in parentheses right here. In other words, we're going to treat it as if this looks like f minus g of x. This is the same thing, we're just omitting the x here, which in composition terms means the same thing. So if we had it like this, it would be f of x minus g of x. All three terms, this, and this, mean the same thing. Just getting familiar with the notation. Now I'm pretty sure we know how to deal with this because we know f of x right here and g of x right here. So let's go ahead and subtract them, and we should get an expression since we're not evaluating at a given value. So let's see what this looks like. We have f of x, which is 3. Let's go ahead and put it in parentheses so we know we're substituting just for the first one. 3 plus 2x minus x squared minus, now anytime we have a minus sign, we always want to write the second one in parentheses. so we don't lose a minus sign. We're actually going to be distributing. We're subtracting the whole expression, the whole function. So we have x minus 2. We can drop the parentheses over here, 3 plus 2x minus x squared. We're going to go ahead and distribute this minus sign, or this minus 1, if you want to think of it like that, into the parentheses here, which gives us a minus x, and minus 1 and minus 2 is a plus 2. All right, now we're not evaluating at a particular point or a given value, so we can just simplify this and be done with it. Now, whenever we have multiple degrees or multiple, we have different exponents. We have an exponent of 2 here and 1 here. We want to put it in descending order. We want to put the biggest exponents on the left. So we have minus x squared out front. We can mark these off as we go. Combining like terms, we have plus 2x and minus 1x gives us a plus 1x. We have 3 plus 2, which is 5. And this is our answer, our expression. All we simply did is simplify. We're just getting familiar with the notation. All right, let's do another one. Let's say we have a quotient, let's say we have a quotient f of g, or f divided by g of 1. All right, so we have a number here to evaluate in this problem, so let's go ahead and rewrite this as the quotient f of 1 divided by g of 1. All right, so we know what we're doing here. We added them up here. We subtracted them here. Well, now we're just going to divide. And excuse me, my computer's freaking out. So we have f of 1, which is going to be f of x with 1 substitute in for x. So we have 3 plus 2 times x, which is 2 times 1, minus x squared, which is just 1 squared. Notice we have a positive 1 in the parentheses, so we're going to be subtracting 1 squared. All right, so we're going to have our minus sign. This isn't going to be minus 1 squared, which would give us a positive 1. This is going to be minus 1 squared, which is minus 1. So let's be careful with our signs here. We have g of x, which is x minus 2, so just 1 minus 2. And we simply do the math. We have 3 plus 2 times 1 is 2, minus 1 squared, which is 1, divided by 1 plus a negative 2, which is minus 1. 3 plus 2 is 5. 5 minus 1 is 4, divided by negative 1, which will simply give us a minus 4. All right, so minus 4 is f divided by g of 1. So we're simply writing compositions here. Let's go ahead and clear a little space. We have time to do one more. Let's do a product. Let's say we have f times g of x. So f times g of x. Now here we can actually only multiply and simplify because we have an x here. We know how to multiply two functions together, so let's go ahead and do that. We have f of x, which is 3 plus 2x minus x squared. Since we have x here, it's the same thing as substituting x in for our function everywhere we see for x. So actually nothing's going to change. If we add a different variable here, is like y, we would plug in y everywhere we see for x in our function. So we should know how to do this by now. We're multiplying f of x times f of g, or excuse me, f of x times g of x. So we have x minus 2. And we know how to do this. We know how to multiply this out. All we do is multiply each term in the first polynomial times each term in the second polynomial. So we have 3 times x and 3 minus 2. So we have this equals 3x. 3 times minus 2 is minus 6. Next, 2x times x and 2x times minus 2. So we have plus 2x squared. We're simply when we're multiplying like bases, we add the exponents. We'll actually cover that in a later section on exponential functions. 2x times minus 2 is minus 4x. And minus x squared times x and minus x squared times minus 2. That'll give us a minus x cubed and a plus, for multiplying two negatives, plus 2x squared. Now once again, we want to write our exponents in descending order. So we have a minus x squared, or excuse me, minus x cubed. We have our x squared terms. We have 2x squared and 2x squared, and that'll give us plus 4x squared. And cancel or mark those off. So we have positive 3x and minus 4x gives us a minus 1x, or just minus x, and then minus 6. And that's all we can do. This is fully simplified. We're working with compositions here. We're given the two functions, f of x and g of x, and we're learning how to write them in different ways called compositions. We're adding them together, subtracting and multiplying and dividing, and we're just giving them a couple different looks. These are called compositions. We'll do a few more in the next video, so I'll see you soon.